So, I want you to picture a quiet, heavily air-conditioned conference room.
Okay, setting the scene.
Yeah. Somewhere deep inside the headquarters of a major tech company. I mean, you would instantly recognize the logo on the building.
Right.
And around this massive wooden table, you have the company's most senior engineers, directors of cybersecurity, maybe even a few C-suite executives.
The heavy hitters.
Exactly. And they are all just staring at a screen at the end of the room, completely paralyzed, like nobody is saying a word.
Wow, just total silence.
Total silence. Because on that screen, there is a list of codes scrolling by.
Mm-hmm.
And it just keeps scrolling endlessly.
And let me guess, these aren't just minor bugs.
No, not at all. These aren't theoretical glitches that might cause an app to crash if you press the wrong button.
Mm-hmm.
The room is staring at a live feed of massive, fully exploitable, zero-day vulnerability.
Which, just for anyone who might not live and breathe cybersecurity, a 0-day is the industry term for a flaw so secret and so dangerous that the software creators have had 0 days to prepare for it.
Like, there is no patch. If an attacker knows about it, the door is just wide open.
And the absolute worst part for the people in that room, this list scrolling by is full of flaws sitting right there in their live production code.
Oh, man.
Yeah, vulnerabilities that have existed for decades, just hiding in the foundational architecture they built their entire company on.
That is a genuinely haunting image.
Right. And nobody in that room reaches out to hit pause on the scroll. They just sit there in silence, watching the digital foundation of their empire unravel line by line.
You really have to put yourself in the shoes of those engineers to realize the sheer weight of what they are looking at. I mean, they aren't just seeing a few coding mistakes.
Yeah, 'cause it's way bigger than that.
They are looking at sudden, undeniable proof that the automated tools and the brilliant human experts they trusted for an entire generation had completely missed massive structural cracks in their most critical systems. Everything they thought was secure just wasn't. And that specific scene, or at least one nearly identical to it, played out at 12 of the most powerful technology organizations on Earth this past spring.
It's just wild to think about.
It really is. And today, we are pulling from a fascinating piece of reporting by Aaron Rose over at tech-reader.blog. The article is called "The AI That Saw Everything."
It's a great piece.
It is. And our mission for this deep dive is to understand exactly what happens when an artificial intelligence model becomes so devastatingly good at finding flaws that it accidentally breaks the entire cybersecurity industry.
Which it absolutely did.
Yeah, and we're going to explore how the biggest tech companies formed a deeply secretive coalition to handle the fallout.
And I think it's important to point out why this matters to you, the listener.
Definitely.
Because this isn't just an abstract story about computer programming. This is about the hidden, fragile foundation of the entire digital economy that you interact with every single day.
Every single day.
Yeah. Every time you swipe a credit card at the grocery store, or send a secure email, or log into a cloud service, you are relying on the very infrastructure this AI just tore wide open.
So to get into it, the event that kicked off this entire paradigm shift takes us back to April 7th, 2026.
The big day.
Right. On that Tuesday, Anthropic did something practically unheard of in the current AI arms race. They built their most capable model to date, a system called Claude Mythos Preview, and upon seeing what it could do, they completely refused to release it to the public.
Yeah, they just locked it down in their own servers.
So Anthropic realizes they've essentially built a skeleton key for the internet. And what do they actually do with it?
Well, reading through Aaron Rose's reporting, the sheer scale of what Mythos was uncovering in its very first weeks of internal testing is just mind-boggling.
It's unbelievable. It started finding zero-day vulnerabilities by the thousands across every major operating system and web browser in widespread use today.
And to really grasp the gravity of this, we need to look at the mechanics of what it was finding. Because it wasn't uncovering fresh mistakes in newly written code.
Right. It was finding old stuff.
Exactly. It was finding ghosts. Like, in one specific instance, Mythos uncovered a 27-year-old denial-of-service flaw buried deep inside OpenBSD's TCP/IP stack.
Let's translate that for a second. The TCP/IP stack is basically the fundamental language that computers use to talk to each other over the internet.
Right.
It's the post office of the digital world, basically routing every packet of data. And a 27-year-old flaw means that code has been sitting there since the late 90s.
Which is insane.
Right. It survived the Y2K panic, the dot-com bubble, the invention of the smartphone. I mean, all of it, just hiding in plain sight.
And we have to ask why. Why did a flaw sit in the Internet's post office for almost 3 decades?
Yeah, how does that happen?
The answer really lies in human psychology and cognitive fatigue. When human reviewers look at legacy code, code that has supposedly just worked for 20 years, they suffer from a kind of snow blindness.
Like they just gloss over it.
Exactly. They assume that because it hasn't broken yet, it must be secure. But Mythos lacks human fatigue or assumptions. It reads 20-year-old code with the exact same ruthless scrutiny as code written yesterday.
Which led to an even more terrifying discovery, right?
Yeah. A 17-year-old remote code execution vulnerability in FreeBSD's NFS server.
And an NFS server, just to clarify for everyone, is how servers share files over a network. It's like the digital filing cabinet.
Yes. And this specific flaw, which finally got the formal designation CVE 2026-4747, was a nightmare scenario.
Oh, wow.
It allowed an unauthenticated attacker to gain root access.
Meaning what, exactly?
That means someone on the other side of the planet, with no passwords, no credentials, and no inside access whatsoever, could completely take over the affected machine with the highest level of administrative control.
Okay, let's unpack this. It's like buying an old majestic house, and an inspector casually points out that the foundational beams have been missing for 20 years, but the house only stayed up because the wallpaper was holding it together.
That is a perfect analogy. Because what's fascinating here is the pedigree of the systems we are discussing.
Right.
We're not talking about obscure, abandoned hobby projects maintained by one guy in his basement. The operating systems Mythos was auditing are the bedrock of the global internet.
The biggest of the big.
Exactly. These specific systems have been reviewed and audited repeatedly by the most brilliant, highly paid cybersecurity minds on the planet. They ran automated security scanners over them millions of times.
And nobody found them.
Nobody. But Mythos just found them, as the article notes, quote, in passing.
I mean, that has to be incredibly humbling, maybe even insulting to the engineers who dedicated their entire careers to securing those systems.
Oh, absolutely.
But Anthropic is now holding a tool that could literally dismantle the internet overnight. They can't release it, but they clearly aren't going to delete a multi-billion-dollar breakthrough either.
Well, they'd never do that.
So they carved out a third path. They created Project Glasswing.
And the nomenclature there is actually incredibly revealing.
Okay.
The project is named after the glasswing butterfly, which is a species native to Central and South America.
Okay.
Its wings completely lack the colorful scales of other butterflies, making them nearly transparent.
Oh, that's interesting.
Yeah, so it can be resting on a leaf right in front of your face, completely visible, yet entirely invisible to the naked eye. And Anthropic's engineers used that as a metaphor for these software vulnerabilities.
Because they've just been sitting there.
Right. Sitting in the code for decades, fully visible to anyone who cared to look, yet effectively invisible to every human and tool that ever tried.
So to handle these invisible flaws, Anthropic assembled a coalition. They brought together 12 organizations to use this model defensively.
Biggest players.
Yeah, the list Aaron Rose provides includes AWS, Apple, Broadcom, Cisco, CrowdStrike, Google, JPMorgan Chase, the Linux Foundation, Microsoft, NVIDIA, Palo Alto Networks, and Anthropic themselves.
And you know, a cybersecurity analyst quoted in the piece described this not as a corporate partnership, but as a treaty.
A treaty?
Wow. And that framing is vital to understanding the stakes here. These 12 entities represent the physical and digital pillars of modern infrastructure.
Basically the whole internet.
Pretty much. You have the major cloud providers, the global financial clearinghouses, the hardware chip makers, the dominant operating systems, and the world's largest network security firms.
So everyone who matters.
If you possess an AI capable of shredding digital security, these are literally the only hands you want holding it first because they own the blast radius.
Yeah, and Anthropic even threw in $100 million in usage credits to the participants, plus $4 million in direct donations to open source security organizations.
Just to grease the wheels a bit.
Right. But I have to stop and push back here for a second.
Sure, go ahead.
I am looking at this list of companies: Apple, Google, Microsoft, Amazon. These are cutthroat competitors who will drag each other into a decade of litigation over the design of a smartphone bezel, you know?
Oh, absolutely.
So you're telling me there are armies of corporate lawyers just agreed to hand over their most sensitive proprietary source code to Anthropic to be scanned.
It does sound crazy.
It sounds like a corporate espionage nightmare. Like, I cannot imagine a world where Apple voluntarily sends its iOS source code to a server controlled by someone else.
And your skepticism is entirely warranted. If the proposal was, hey, email us your code, the lawyers would have shut down Project Glasswing in 3 seconds.
Right.
But that isn't how the treaty functions. The access architecture is designed around an API-secure pipeline, which is essentially a highly controlled digital dumbwaiter.
Okay, a dumbwaiter.
Yeah. Mythos, the AI model, never leaves Anthropic's secure servers. But, crucially, the partner's proprietary code never permanently leaves their own machines.
So how does that actually work in practice?
So an engineer at Microsoft, for example, sets up a secure encrypted tunnel to the Mythos API. They feed a localized segment of their code into the dumbwaiter, send it up to Mythos. The AI analyzes it in real time without storing it, and then sends the analysis back down. There is no human at Anthropic looking over the data, and the data isn't retained to train future models.
Wow, so it's totally sealed off.
Completely. Furthermore, the agreements are bound by incredibly strict legal parameters. The API is locked for defensive use only. A partner can only point Mythos at code they legally own.
Oh, I see.
And Anthropic retains full, continuous audit rights to monitor the queries, just to ensure nobody is using the AI to reverse engineer a competitor's product or build offensive cyber weapons.
Okay, that structural limitation definitely makes the corporate cooperation believable. They basically built a vault where everyone can use the microscope, but nobody can steal the slides.
That's a good way to put it.
But how do we know this actually works in the wild? Did any of these companies actually let this thing loose on their live code bases? And what was the experience like for the engineers on the ground?
Well, Cloudflare actually provided a very transparent public account of their initial Glasswing session. They pointed Claude Mythos at over 50 of their own massive code repositories.
Oh, wow. 50 of them.
Yeah, and what their engineers observed fundamentally changes the paradigm of automated security. Because for decades, traditional security tools have operated as pattern matchers.
Meaning they just look for things they already know are bad.
Exactly. They scan through code looking for known, pre-programmed shapes of vulnerabilities. They essentially operate on a massive checklist of do not do this rules.
Okay, so a traditional security scanner is basically a rudimentary spell checker.
Yeah.
It scans your document, finds the letters TEH strung together, and flags it so you can change it to THE. It's catching obvious mistakes based on a pre-existing dictionary of known errors.
That's spot on.
But Aaron Rose's article makes it clear Mythos isn't doing that. If the old scanner is a spell checker, Mythos is acting like an elite literary critic.
Oh, I like that.
Right. It doesn't just read the words, it reads the entire manuscript for context. And then it points out that an alibi provided by a character in Chapter 2 completely conflicts with a train schedule established in Chapter 12.
Which destroys the logic of the whole book.
Exactly.
That is a phenomenal way to visualize the mechanism at play here. Because Mythos is performing cross-code-based reasoning. It doesn't look at one line of code in isolation.
It sees the big picture.
Exactly. It traces complex multi-step chains of logic. So it might identify a tiny, seemingly harmless quirk and how memory is managed in one component.
Just a little quirk.
Yeah, and on its own, that quirk isn't a vulnerability, it's just a sloppy line of code. Then it looks at another minor inefficiency in the user authentication module.
Okay.
Separately, they're totally benign. But Mythos possesses the cognitive bandwidth to figure out how to combine those two unrelated quirks to create a devastating exploit that neither could produce alone.
That's terrifying.
It literally thinks like a creative, elite human attacker looking for the unexpected ways different systems collide.
And the scale at which it applies this reasoning is staggering. The article notes that AWS used Mythos across a technology stack that handles more than 400 trillion network flows every single day.
Which is an unimaginable amount of data.
400 trillion. And Cisco and Microsoft both reported that they were identifying and categorizing vulnerabilities at a pace that their senior engineers previously considered mathematically impossible.
I mean, on paper, this sounds like the ultimate victory for cybersecurity, right?
You would think so.
The coalition is working, the invisible flaws are being found, and the internet is about to become an impregnable fortress.
Well, here's where it gets really interesting.
Okay.
Because you'd think these 12 companies would be taking victory laps in the press. But Aaron Rose drops a statistic in the middle of this piece that completely reframes the entire narrative.
It really does.
As of his writing, fewer than 1% of the vulnerabilities found by Mythos across all the Glasswing partners have actually been patched. Less than 1 in 100.
It is a profoundly jarring number. You have thousands upon thousands of critical flaws identified in the most vital software running the modern world, and 99% of them are still sitting there, exposed, entirely unfixed.
So what does this all mean? If you are listening to this deep dive on a smartphone right now, or if you checked your bank balance this morning, the math suggests there are newly discovered, highly dangerous vulnerabilities sitting in those applications right this second.
Yeah, that's exactly what it means.
Are these companies just negligent?
Not at all. This isn't a failure of effort by the Glasswing partners, and it certainly doesn't mean their code is unusually bad compared to anyone else's.
Okay, then what is it?
What we are witnessing is a fundamental structural crisis in how software engineering operates. For the very first time in the history of computing, these massive corporations can see all of their flaws at the exact same time.
So going back to my house analogy, they didn't just find one termite-damaged beam. They were handed a mapped-out schematic showing that 300 beams are technically compromised.
If we connect this to the bigger picture, the crisis comes down to a brutal discrepancy in time.
What do you mean?
Well, artificial intelligence operates, and cyber attacks occur at machine speed. Mythos can ingest, read, and cross-reference 10 million lines of code in seconds.
Right.
But defenders, the human engineers tasked with actually fixing the code, are forever trapped working at calendar speed.
Because fixing a vulnerability deep in the architecture of a global banking system isn't just a matter of hitting backspace and typing a new line.
Exactly the opposite. The triage pipeline for a single core vulnerability is agonizingly slow.
I can imagine.
First, a human expert has to verify the AI's finding to understand the blast radius. Then they have to route it to the specific engineering team that owns that component.
Which takes time.
Right, and that team has to write a patch. Crucially, they then have to run regression testing to ensure that fixing the bug in component A doesn't accidentally cause components B, C, and D to catastrophically crash.
Right, you don't want to break the whole system just to fix one bug.
Exactly. Then they put it in a sandbox environment. Then they do a phased rollout to a fraction of users. Finally, they deploy it globally.
And how long does all that take?
That process takes days, weeks, or even months for a single severe bug. Meanwhile, Mythos is churning out hundreds of new vulnerability tickets every single hour.
Oh my God.
The backlog is growing exponentially faster than human hands can ever hope to address it.
Which brings us back to the psychology of that conference room at the beginning of our deep dive. The reason those executives were staring at that scrolling screen in silent horror wasn't simply because they were shocked by the bugs.
No, it was the realization of what came next.
Right. It was the crushing realization of the math. They were watching an impossible mountain of labor being generated in real time. They realized they could never climb it.
Never.
And that profound vulnerability led to one of the most ironic twists in the entire Project Glasswing story.
Yeah, we can call it the transparency paradox.
Right. We talked about how Anthropic named the project after the Glasswing butterfly to symbolize radical transparency, bringing the invisible into the light.
Beautiful metaphor.
Beautiful metaphor. But the actual rollout of this historic project was entirely opaque. It was shrouded in secrecy. And the twist is, Anthropic didn't impose that initial gag order. The partners themselves demanded it.
It is a highly revealing corporate reaction. I mean, you have these 12 massive organizations, heavily equipped with armies of legal counsel, crisis managers, and PR teams.
You're used to this stuff.
Exactly. They're completely accustomed to navigating public disclosure and taking their lumps in the press. But when they saw the sheer volume of what Mythos was finding, their institutional courage just evaporated.
They panicked.
They absolutely panicked. They legally insisted that their findings be locked in a vault, heavily encrypted, and hidden even from the other partners in the coalition.
Because they realized that if anyone, even a friendly partner company, knew the true, mapped-out extent of their vulnerabilities, they would become the biggest targets on the internet. They pulled the curtains closed on the very project designed to open the windows.
It highlights just how fragile the tech giants know their own ecosystems really are.
It's scary.
It is. However, Aaron Rose notes that this hyper-defensive posture has just recently begun to shift.
Oh, really?
Yeah. As of the week of his publication, Anthropic and the partners successfully negotiated a revision to those confidentiality arrangements. The Glasswing partners are now permitted and increasingly encouraged to share their findings.
Okay, through standard responsible disclosure protocols, presumably, like they aren't just posting a list of 0 days on a public forum for hackers to find.
Naturally, they are establishing secure back channels to share these findings responsibly with federal regulators, government cybersecurity agencies, independent open source maintainers, and eventually the public, once mitigations are in place.
So they're slowly opening up.
Yes. The goal is to allow the wider digital ecosystem to start bracing for impact and patching their downstream systems. The butterfly is, slowly, becoming visible to everyone.
So where does this leave the digital world right now? What is the current boundary of what we are dealing with?
Well, right now, Project Glasswing is strictly a discovery program.
Okay.
It operates on a strict division of labor. Mythos finds, humans fix.
Right.
And the entire tech industry is holding that line with a white-knuckle grip because they have to.
Because we simply aren't ready for the alternative.
Exactly. We aren't ready for the legal, operational, and safety nightmares of letting an AI autonomously rewrite production code at the scale of the global economy.
I mean, imagine an AI attempting to patch a minor network bug and accidentally bricking the global SWIFT banking system in the process.
Yeah, the cascading failures and liability issues of autonomous patching are currently insurmountable. But this raises an important question that the industry is going to have to face immediately.
What's that?
The current dynamic, where an AI continuously generates an infinite list of critical flaws that humans can only patch at a sub 1% rate, is entirely unsustainable.
Yeah, the math doesn't work.
You can't outrun a sports car on a bicycle. And Aaron Rose actually teases a part 2 to his reporting, focusing on the inevitable shift from finding to fixing.
Oh, interesting.
Yeah, he calls this upcoming phase client in the loop. It's the realization that the endless list of bugs Mythos is generating isn't just a static security report.
It's a starting gun.
Exactly. It's a race.
And it is a race that, right now, humanity is losing on time. Which leaves us with a rather chilling scenario to consider.
Yeah.
We know that Anthropic built an AI capable of instantly mapping out decades of invisible flaws in our digital infrastructure.
Right.
And we know that human engineers require months or years to safely patch them. So what happens the day a malicious actor, like a hostile nation state or a well-funded cybercriminal syndicate, builds a language model just as smart as Mythos?
That's the nightmare scenario.
We finally solved the problem of finding the hidden holes in the hull of our ship, but until we can patch them at machine speed, we're really just giving ourselves a crystal clear view of the water rushing in.
That's a terrifying thought.
It really is. Think about that next time you log on to, well, anything.